Hey folks, today we're gonna look into something super cool. So we're gonna deploy Exadata dedicated infrastructure together with VM cluster in AWS. So a lot of times you don't really get access to play around with Exadata, so it's part of the deployment. I luckily got my hands on one, so we're gonna deploy the Exadata infrastructure and then the VM cluster on the ODB network, which we're gonna create, and then we're gonna look a couple of other things like ODB peering with VPCs or VPC, and then also DNS, how it's configured. Everything is pretty much like really well documented in the AWS documentation, and same likewise with the Oracle documentation, but nevertheless we're gonna look on the steps what are required so that if you ever get to deploy one, then you'll have some kind of idea what's required. So let's take a look on what do we really need. I think the best way maybe to explain what's required is just to visualize everything. So there's gonna be basically three main components what we need to build, and then some additional things on top of that. So what we're gonna need ODB network. So that's gonna be one, and then we're gonna need the Exadata infrastructure. Let's put it here. We're gonna need the infrastructure. Gonna need the VM cluster, and I'll explain these shortly. So Exadata VM cluster. Then we are gonna need AWS VPC, and then finally we are gonna need some ODB peering between the VPC and the ODB network. So let's actually put the network. So network is gonna be something we create first. So we'll create the, let's put this on the side. So we'll create the ODB network, and then we'll give it the CIDR block. Basically the network requirements are specified in the documentation. So I think the /27 is the minimum that you can give nowadays, but we will give basically a /24 CIDR block for the client subnet. So if you ever deploy Exadata on OCI, this is pretty straightforward. We're gonna need a backup subnet CIDR block as well, but the ODB network will be the client subnet. Then we are gonna create the infrastructure as a second step, and then what we are gonna create the VM cluster, and let's actually take the color out from the infrastructure as well. So how I like to think this is that the infrastructure obviously can span to different clusters, so you can have multiple VM clusters within one Exadata infrastructure, and then those VM clusters, they can be either on the same ODB network or different. So you could have basically a second ODB network with the different CIDR block, and then you could have a second cluster using the same infrastructure but just on a different ODB network, and then you could pair these VM clusters with the VPC. So we can have a VPC here. Let's move this a little bit on the side, actually here, or actually let's do it this way so it's easier to visualize. So we'll put the infrastructure here, which is shared. So we own the whole infrastructure, but then we can share these VM clusters basically using the same infrastructure. And we'll have the AWS VPC here, and then we'll create this peering between the ODB network and AWS VPC. So this VPC could have your application servers which connect to database, or you can use it sort of like a transit or hub VPC, which then goes to AWS transit gateway, and then you route the traffic. Right now the peering is 1-to-1. I don't know, the AWS reInvent 2025 is next week. Remains to be seen, like if there's any announcements on the networking, but I think like at some point maybe we'll have a way on connecting these ODB networks to multiple VPCs as well. But this is what we are gonna build. So we are just gonna build the infrastructure, ODB network, a VM cluster, and then we are gonna do this ODB peering to AWS VPC. I'm gonna do everything through console, so we could use Terraform, for example, to deploy these, but I think like just for reference we'll use console, so you'll see what it looks like and what we can do from there. Okay. Okay, so I've logged now to the Oracle database at AWS console, or basically it's the AWS account and then just the navigating to the Oracle database at AWS. So you can already have it like bookmarked here, but you can even search just with Oracle, and then you'll find the Oracle database at AWS from here. So if we click here in the dashboard, then it'll take us to this main page, and you can see I already have some pre-created resources. So I actually have one Exadata infrastructure. I have one VM cluster here. I don't have any autonomous VM clusters, but you can also deploy autonomous VM clusters. So you can choose. That's pretty cool. That if you have an Exadata infrastructure, you can now choose that whether you provision like a standard Exadata VM cluster or use the autonomous VM cluster, kind of like the autonomous dedicated. But I think this will be good in the long run, that the people necessarily don't want to invest to full autonomous, let's say fully autonomous dedicated infrastructure, but now you can have the Exadata infrastructure, and then maybe you'll start small. You provision one autonomous VM cluster and go from there. So what we first need to do, we need to provision the ODB network. We'll start with that. So we'll go here. Already have a few resources here created, ODB networks for my clusters. But I'm gonna create a new one. I'm gonna give it the name. Let's give it ODB test network availability zone. So the AC needs to be the same where you have or you're gonna provision the Exadata infrastructure. So that's something that when you're gonna provision it, you have to work with AWS and Oracle, so you'll know which AC you have the Exadata available. So I know mine is gonna be available on this US East 1A, so I'm gonna use that. And then just like in our example, I'm just gonna use this /24 for, you can see backup CIDR optional. We'll just give it, we'll give 51/24. The DNS configuration, you can see domain name to use all resources provisioned for this ODB network, including scan and VM host names. We'll use the default Oracle VCN, so which might be familiar if you've been using OCI. And then we'll just give it the name Exa AWS as a prefix. And then these are quite important here. So network access for AWS service integrations for your ODB cluster. So if you're planning to use Oracle Managed Backups to S3, then you would enable this. You can add like auth policies here. 0ETL. I think this security token service is new. I haven't seen it, but I think it came now with the AWS KMS integration. That came out like 2 weeks ago, like mid-November 2025. So I think this is really important feature as well. So if you check my previous video on GCP KMS, so now we have the same possibility here as well. Let's just choose this STS and KMS. Maybe I'll give it a test later as well, and then tags as well. So now I can just create the ODB network. It'll take like 10 minutes. I'm gonna pause the video for the time being. So while the ODB network is being created, we can actually create the infrastructure already. I do have my infrastructure created, but I'm just gonna show the steps that are required. So navigating here on the infrastructure page, I can click on create Exadata infrastructure. I could give it a name, my Exa infra, for example, and then again this availability zone, so where your Exadata will reside. So right now there's 2 regions which are available with the US East. 1, so A and D, well for me A and D, you can see the actual ones like use 1 AC6 and use 1 AC4 here, which I think are the actual regions. But anyway, so that's important thing to check, like which regions, which availability zones are available. So if you have your resources in specific AC, you want to make sure that the database will be close as well if your application is latency sensitive. So now we'll just go on the next page, and we can choose here whether we use X11M or X9M. So one thing to note, like with the X11M, then the model, CPU model is eCPUs. So just plan accordingly that you have to understand eCPUs as well. And you can see like one server has 760 eCPUs and 1.5 RAM per server, and then which you can then allocate to the clusters. And then storage server, which is minimum is 3, so you'll get 240 terabytes total usable storage when you deploy this cluster. And I could add more if needed here. So let's say I need actually 3 database servers, so I could just slide it here to 3, and then 5 storage servers if I need more storage, and I could do that as well. The next is maintenance settings. So if you wanna customize the maintenance schedule, how you're gonna do rolling patching, for example, so only 1 server at the time, no downtime overall, and then any other customizations here, and then just a review here, basically what you're gonna create. So very similar experience as with Azure and GCP as well. So obviously it's the same resource or service everywhere, so makes sense that everything is similar. So if you've done this in OCI, it's pretty familiar how you need to do it here as well. I do like the look and feel with the AWS console. It's quite slick in a way that it's easy to configure. And then I would just create the Exadata infrastructure. It takes around, like, it doesn't actually create anything yet, rather than obviously on the background it allocates the Exadata to your account and so on. So I think when I created the Exadata infrastructure, it took me around 40 minutes overall. Okay, so now we are just gonna wait that the ODB network finalizes the creation of it, and then we're gonna move forward. All right, now the ODB network is created as well. So, and you might notice like the CIDR blocks are a little bit different when I created. So I had to actually recreate this. It failed a couple times. I couldn't actually figure out like what was the reason. Like finally it worked when I just enabled basically all the options. So I enabled the S3, 0 ETL. Well, 0 ETL seems disabled. Maybe I need to do a little bit more work. Never used this one, S3, and then the security token service is enabled as well. So might as well try the KMS later on. but couple things here. So you'll see the, after it's created, you see the client subnet range, the backup subnet CIDR, and then on the DNS configuration you can see the basically what we gave as the name here, and then what AWS does, they add this client dot in the on the starting point of the domain name. So you'll see always this client here regardless. So that was like one thing I noticed previously. And then for the DNS, which we'll be doing later, there's a listener which has an IP here as well. And I can go here and check the OCI resources. So basically there's a network anchor and then some other basically details for the connectivity as well, what they've created. So if we would go on the OCI side, OCI console side, we would see this same ODB network created as well. So let's take a look on that. So I think it's good to understand that you'll see basically the same resources, like the network resources on the OCI side as well. So just to validate things, just to troubleshoot, like you'll go similarly, like if you would work on the OCI side, you would go on the VCNs, and then you can see, for example, here is the ODB test network. You can see that Oracle adds this VCN here, automatically VCN dash, and then it has the CIDR block that we've done. And you can find them, like what they do is basically they create this multi-cloud link and then compartment, and then there will be this OCI resource anchor compartment as well with my account number on the AWS side as well. So I can then find like all the networks here as well. And then I can drill down on this network. I'll have the client and backup subnet here as well. And you can see client subnet, backup subnet, they are here as well. Some additional things like obviously routing, there's a default route table and nothing really out of the top here. So you'll see like there's a link towards DRG, and then also service gateways is added there automatically as well. So that's something to know, that on the OCI side you can see these as well if you need to troubleshoot or validate things as well. Okay, so we are back on the let's make this a little bit, no, I think it's okay, we can see it. So back on the Exadata VM clusters on the AWS side as well. So we'll now create the VM cluster. So now I'm just creating a standard VM cluster. So I'll give it the name. Let's just give it like test VM cluster, and I could give a grid infrastructure cluster name, then time zone where I'm at. Let's just have like we'll have like a Toronto since I'm based there, and then license options, bring your own license or licensing included. So you can do this per cluster if you need to. And now we'll just click next, and then we'll choose the infrastructure. We'll choose the grid version. So you can see I have 26 and 19 available, and then we'll use the latest Exadata image version. And now basically whatever database servers I have, I can choose like which physical servers I'll use for my virtual cluster here. So minimum is 1, and now I only have 2 database servers here in my Exadata, so I'll choose both of them. And you can see like how much eCPUs and memory and local storage I have available here as well. And you can see eCPU core count. So this is per VM. So per VM, I think the minimum is now 8. If you remember, with OCPUs, the minimum was 2 OCPUs per node. So one OCPU is averaging for eCPU, so 8 is the minimum right now. So we'll just go with the minimum. We'll give let's give like 256 gigs of memory, and then local storage we'll give like let's give like 300 gigs. So these are basically what you have like available to play. Like if you have multiple clusters, you have to take this sizing, basically plan the sizing as well, how you're gonna do it, and then per cluster how much storage I'm gonna allocate. So we'll only need like 4 terabytes out of the 240 terabytes that I have available here. And then on the storage, obviously I could allocate storage for local backups, and then if I would use Exadata sparse snapshots, I could do that as well. And this obviously changes the storage allocation, you can see here, and then how it would go. This is same as in OCI, so nothing new here as well. Okay, and then on the next one, basically we can choose our test network for the ODB, hostname prefix. If I would give a hostname, let's just give it like this will be our first cluster, so Exa1, and then host domain name, and you can see then FQDN for the VM cluster will be exa1.client awsexa.oraclevcn.com. A scan listener port can give like a specific ports if I want to. I don't need to use the default one, and then I'll give a SSH key pair or the public key pair here, basically, or the public key, sorry, here, and then I'm basically ready to validate that. So I'm just gonna copy the public key here and then continue. Alright, I have my key copied here, just gonna click next. And I can enable diagnostics similarly as in OCI, and why I keep referring to OCI is just to point that same functionality is available here as well. So now that's just next, and then reviewing basically what we did, and then now I'm ready to create the cluster. So I'm gonna click the create VM cluster. This takes around, let's say, 4 to 6 hours, give or take. So let's see how long it takes this time. Just gonna pause the video and continue once we are done. So it didn't actually take too long, maybe like 2.5 hours. So I think previously, at least maybe with X9M, it's been like 4 or 5 hours, but maybe my info is a little bit outdated on that. So seems to be like 2.5 hours. I had this test VM cluster up and running. So when I go here, then status is available, all the information is here, infrastructure, licensing, connectivity. So you can see the scan DNS name here. It's basically now with the Exa1 dash, and then whatever they add there to make it distinct. And then connectivity, we can see details on the ODB network and everything. So one thing, when I did this last time, the ODB peering, I had to do it via the AWS console. So now I think we looking at the documentation here is basically what they are saying is I should be able to do it through the console. So let's just try it out to see if it works. So we'll also, and I have one AWS VPC pre-created as well. So let's see, ODB peering test, and we'll select the ODB network. It's our test network here. Gonna choose this, and peer network is gonna be just gonna check the VPC quickly. Too bad they don't tell the name here. I'm just gonna check the VPC what I'm gonna use. Okay, It was this 3PC that I had to pick up, and then side arranges in peered VPC that require access to the ODB network. With the peering connection, you can control which part of your ODB network are accessible. It's optional, so I'm just gonna leave it as is, and then I'm gonna click the create ODB peering connection. All right, now it's gonna be provisioning, so I'm just gonna pause the video and wait for it to complete. And while we are waiting, just gonna show from the documentation, and I think we still have to do this manually. I just remembered it wrong. So the ODB peering we can do via console, but then these VPC route tables for ODB peering, we basically have to use the AWS CLI with this create route command. So what I need basically is the route table ID on the VPC and subnet, which is the AWS VPC, and then destination CIDR block is gonna be our 1040.0.0/24, which is the client subnet, and then I need to get the ODB network ARN, which I'm gonna then use for the peering. So if I go here, I'll check the ODB networks. I'm gonna go to the test network, and then I'll get the ARN here. So I'm just gonna prepare the command to have it ready once the peering is created. So I have the ODB peering now created. Connection is here, and the next thing we'll do, we'll run CLI with the command which I already pasted here. So right now in the AWS VPC subnet, we only have the local route. So we need to run this command to create the route. So let's run it and return true. And we're just gonna refresh routes and see now we actually have the 1050/24 route here, and the target is the ODB network here as well. So now we have the peering, we have the routing, and then the only thing we are still gonna do is basically DNS. So let's think on the DNS a little bit. If we go in the cluster, VM cluster, we can see that it has the scan address, which is the oraclevcn.com, and then on the AWS VPC, if you want to connect using that scan, we obviously have to resolve it. So one way, what the documentation says as well, is that it's basically explaining how DNS works in Oracle Database at AWS. There's gonna be a private resolver listener automatically created on the OCI side, and you can see a DNS listening endpoint within the OCI VCN for the private DNS resolver. So if you are familiar with OCI networking, this is quite common, but even with the knowing AWS networking, I think you'll figure it out quickly. Obviously, the normal, let's say when in real life the DNS configuration might become more complicated. Maybe you want to use custom DNS for the Exadata hosts, and that's perfectly fine as well. But I think in many cases you end up using the Oracle VCN, and then maybe you need to resolve the scan address only. And you can use a specific scan if you can basically resolve it to those three scan addresses, so you can configure your own scan in your DNS on top of everything as well. But for this exercise, we are just gonna configure this. So if I look on the drawing we did earlier, I just added this basically DNS listener endpoint. So that's where it's listening any queries, and then we're gonna create this Route 53 outpoint endpoint in our VPC and subnet what we created, and then any queries for that oraclevcn.com domain, then they're gonna be forwarded to DNS listener endpoint. And just to add, like in some cases, if you have to resolve hosts outside of the ODB network from the Exadata VM cluster, you can also create a DNS forwarder on the OCI side. So you'd have to go to the OCI console so that the Exadata can actually resolve or forward the domain queries towards the AWS VPC or wherever, like an on-prem DNS server, what you might have. So the traffic would then go through the ODB peering to AWS VPC and then forward from there again. So it can become tricky fairly quickly, but it's just something I'd keep eye on or think early on how you're gonna manage DNS. So let's go on creating all of this now. So for the DNS, we basically have to do two things. We have to create the outbound endpoint, which is done here from the Route 53 dashboard or console, and then the other one will configure the outbound rule or the forwarder rule, whatever we want to call it. So here we'll just go on the outbound endpoints. I do have one here already created for the other cluster, but now we are going to create one for the ODB outbound endpoint for our test cluster. We're going to associate that with our test VPC. Gonna select the security group which we have available there so that the traffic is allowed. Remember to have they also have that specified in the documentation, so which rules basically you need, but so obviously the DNS traffic that needs to be allowed. And then endpoint type, we're just gonna have IPv4, and then protocols, we will keep it with the DO53. All right. Availability zone, basically we'll have the US East 1A, and then we'll have our only subnet in that VPC as well, and I'll let it choose it automatically. We could choose obviously another IP address here. We'll just do it as well, and then choose the same subnet, and then we can just create the outbound endpoint. Just gonna pause the video while it's being created. Now our outbound is created here. So the next thing to do is basically creating the rule. So we need two things for it. So we'll need the domain name and then the listener IP. So we'll just go on the console on the VM cluster, and here you can see the DNS listener IP and the domain name. Both can be found from here. So we need to go back to the Route 53, and then we'll create a new rule here. So we'll just create like a ODB test rule, forward queries. Then we'll have the domain name. So this will be the client.aws exa. Just a small thing, like it doesn't really matter. Like I just like I won't say dislike, but this client being here automatically, I think maybe it could be something in the future we can use our own naming, hopefully, but nevertheless doesn't matter so much. And then choose VPC. We're gonna choose our test VPC here, and then outbound endpoint, we are gonna use the test one that we just created, and then target IP is gonna be the listener IP that we created, and then we're just gonna create this, and then after it's created, we should be able to resolve the scan address and connect to the nodes using my EC2 instance, which is running on the AWS VPC. So let's create this rule. So now it's there. Gonna pause the video, log into my EC2 instance, and then we're gonna test that we can resolve everything. All right, just a small correction. So the DNS configuration you find under the ODB networks, not under the VM clusters. but we do want to get the scan address now from the VM clusters. So I'll just go to my VM cluster here and then get the scan DNS name here. I'll just copy it, go to my EC2 instance, and this instance is now in the AWS VPC, which is paired with the ODB network. So I'm just gonna do NS lookup, and let's see, then press enter. So you can see it resolves all the 3 scan addresses here as well. And then likewise, like I can still go on the cluster, I can check the virtual machines, and I can see the cluster names. So I could actually SSH here. Let's actually take a look on that. So I'm just gonna go back here, and then just gonna SSH. I need to use my key, so I'm just gonna bear with me. Okay, so I just copied the node name here, and then have the, remember when we provisioned the cluster, we gave it the SSH key, so I have it here. And now I can just SSH to my Exadata VM cluster node. So here we are. We should see a lot of database processes and grid processes running. Obviously, Exawatcher, all of these things. So this is it. So not too hard. You just have to know the networking, follow the instructions, obviously plan how you're gonna connect. But yeah, so we provisioned the ODB network VM cluster. We also look how to provision the infrastructure, even though we didn't do it. And then we did the ODB peering and DNS configuration from our AWS VPC. So a lot of things here, nothing too complicated still, but it's just like getting understanding what you actually need to do. All right, I hope you got something out from the video, what we did. So basically, just to summarize, we had to create the ODB network, we create the Exadata infrastructure, we create the VM cluster, then we did the ODB peering with AWS VPC, and then we also configured DNS. So hopefully you saw the provisioning part is really easy in a way that if you've done it before, you can fairly straightforward, like you can do it fairly straightforward, like you used to. I think it's, how I like to say, it's everything around it, like the AWS accounts, the VPCs, how you connect all together, DNS, security, all of those things make it, let's say, not more complex, but it's something that you really have to design and put effort into it, that you plan it properly. But just looking like how AWS and Oracle have done it like together, I think it really works nicely, the integration, provisioning clusters, and so on. Hope you enjoyed the video. Let's catch up next time again. Thanks for watching.